Are we good? Okay. Good morning, everyone. Thank you for joining us today. We are excited to present the transformative potential of generative AI, or GenAI, in the realm of autonomous data operations. As we dive into this exciting topic, we will share our perspective, and we hope to shed some light into how GenAI is revolutionizing data management and the implications it holds for the future. First, let me introduce the speakers. I am Vasileios Linardos, Head of AI Services Department at Archeiothiki, and alongside me is my friend and colleague Michael Sinoplis, our AI Product Lead. We co-founded the AI department at Archeiothiki back in 2019, and it has been an exciting ride since. Now, please allow me to briefly share our journey at Archeiothiki AI Services. For reference, Archeiothiki is the leading data management provider in Greece, spanning from storage of physical files to digital data management services. Over the past few years, we've made significant steps in incorporating artificial intelligence into our operations and data management in general. We started back in 2019 by transforming some operations on how we process data. We were able to test, evaluate, and improves the way AI generates value in data operations, focusing always on what's important, which is seamless integration into existing systems and operation. Our team went a step further by creating the AI line of services, which includes customizing deep learning models trained and tailored to the specific needs of our clients. We have successfully developed and deployed over 50 models across various operations, enhancing our automation capabilities. By leveraging these models, we've processed more than 15 million documents. Now, a major milestone in our journey and timeline has been the integration of GenAI into our systems. We will dive deeper into how we got into that, and bear with us because we will get our hands dirty with some technical details on the way. From the very beginning, we identified GenAI's potential in data operations, and we focused on the development of safe and robust systems and mechanisms to incorporate it in AI complex data workflows. Finally, we have been experimenting with multi-agent systems, and we are always committed to be at the forefront of AI innovation by connecting this rapidly growing field with the challenging, complex, diverse, and unpredictable real-world data management scenarios. Through this journey, we have gathered hands-on experience with AI systems in data operations, and we hope that we can share some insights from this experience with you today. Okay, so the agenda today will begin with a brief overview and introduction of AI data operations. We will discuss the distinct features that characterize autonomous data operations with other data operations. We will explore the role of GenAI in data operations specifically. We will address the risks that involves GenAI and its integration into existing systems. We will see some real-world case studies that we have encountered. And finally, we will take a look on how we see the future of GenAI and data management, followed by, if the time allows, a QA session. All right, so let's delve into AI data operations, which represents a critical component of our data-centric world and already are the backbone of modern data management. These operations encompass a variety of sophisticated tasks that were traditionally handled by technical teams. Today, we employ AI tools to perform operations like classification, data extraction, object detection, translation, summarization, and others. AI data operations stand at the intersection of data science, machine learning, and software engineering, automated processes and that enable us to manage and leverage data at scale. But with the businesses ever more dependent on their data, which is basically a currency at this point, the demand for more sophisticated and increased applications of AI and data operations is escalating rapidly. Misclick. Okay. Moving to the pivotal AI challenge in data operations so far, which is no other than ensuring data quality. In digital age, where the data is akin to currency, its quality is a measure of its value. Quality encompasses accuracy, consistency, completeness, reliability, and relevance, all of which determine the trustworthiness of the data insights that we gather from the operations we apply on this data. However, data often suffers from issues such as errors, noise, and biases, which can lead to misleading conclusions and poor decision-making. Although there are methods to improve data quality, the main challenge still remains, and it critically impacts the performance of existing AI systems. Having explored what AI data operations entail, let's now turn our attention to understanding what are autonomous data operations and how they are distinctively characterized from other operations. The autonomous data operations involve leveraging sophisticated algorithms and machine learning technologies to automate the managing, monitoring, optimizing data across diverse platforms and settings. The key components of systems that handle autonomous data operations are, of course, automation, AI, autocorrection mechanisms which act as advanced mechanisms for error resolution in our systems, and finally, scalability, one of the main objectives of every modern day solution. Now let's talk about GenAI, right? Let's introduce GenAI. Largely powered by large language models, or LLMs, which everyone has heard, GenAI brings a new level of sophistication to data operations. Through extensive training on diverse data, and progressively bigger and more complex architectures, these models demonstrate an enhanced capability for generalization of their skills among different tasks, and in many cases, human-like reasoning quality. But why is GenAI so disrupting and important? What is all the fuss about? GenAI is revolutionizing the way we work with data for a couple of significant reasons. Firstly, GenAI challenges the long-standing garbage in, garbage out logic, right? These systems are not merely designed to handle data, they are crafted to understand it. From a technical point of view, at the heart of GenAI architectures is a denoising process, whereby the models undergo extensive training to ensure their output is coherent and understandable. They learn to discern relationships within data, enabling them to consistently produce accurate and reliable content. Now, this learning process equips GenAI models, and particularly LLMs now, their application is obvious, in textual applications, with the unprecedented capacity to transform noisy or fragmented data into clear and logical outputs. Such a feature that these models learn, right, they're trained to do, is exceedingly valuable because when these models are utilized then, they inherently apply this denoising proficiency that they have learned through training, essentially making some sense out of data that would cripple other AI systems due to their generalization and their ability to perform, let's say, denoising operations, right? Additionally, GenAI brings the advantage of self-correction to the table. GenAI models have the cognitive-like ability to reflect on their output and iteratively refine them. whether they are dealing with text, visual data, or other modalities now. These models can iterate over their own generated content, engaging in a self-improvement feedback loop. Secondly, GenAI excels in its capacity to swiftly adapt to different areas of application. This is a key component for any business use case. A process known as domain adaptation. This agility in switching contexts is a vital advantage, allowing GenAI systems to apply their learning to new and often unrelated data problems without the need for extensive retraining, which involves huge resources and time. Moreover, GenAI retains a robust level of reasoning across the tasks, right? It understands concepts that apply to different situations. An important tool in GenAI's arsenal is feature prompting. This is where it gets a little bit technical. Feature prompting is basically a technique that, by providing a small number of examples to our models or shots, instead of fully retraining them, they still perform effectively in data operations. Instead of feeding thousands or millions of data points, again, requiring resources, you can engineer the way the models will operate by passing these obstacles. Finally, there's domain-specific tuning, which fine-tunes GenAI systems for particular fields with minimal data compared to traditional other methods. This means that GenAI systems can be customized for different industries and challenges more rapidly than ever before without the need of heavy data requirements that used to be the norm. Now, let's see why GenAI is important from an engineer, the inside out, an engineer's point of view. How we, the people who build the systems, view the business problem and the challenge completely differently when having the GenAI in an arsenal and toolkit. GenAI introduces a new paradigm in data management systems through semantic programming, right? Whether we call them agents, GPTs, or assistants, these systems are basically software. These systems are basically software that are developed in a way to act differently and perform tasks where the inputs and the outputs can vary and are unpredictable. So for us, semantic programming is about designing systems that offer deterministic functionality despite having non-deterministic inputs and outputs. In other words, this means that a GenAI-based system is capable of interpreting and processing information that might be vague or variable and still function reliably and with consistency, which is a key component of a software system in production-grade, production-level systems. So consider the example of a GenAI-powered assistant which can accurately schedule my meetings or generate my emails based on my preferences. It can adapt its responses based on the context and content of the interaction, rather than requiring precise commands or inputs, clicks, buttons, whatever. This shows the power and flexibility of semantic programming and the potential of GenAI systems to revolutionize the way we interact with technology in general. With every technological leap, there come some associated risks, something that is very common in AI systems in general. And GenAI is no exception, the contrary. When we delve into the risks of GenAI, we are primarily concerned with its lack of explainability. While traditional AI models already struggle with transparency, GenAI adds layers of complexity that make its reasoning more opaque and make it very difficult to interpret its results. Okay, measurability challenges. This is something new, kind of unique, kind of. GenAI's unique operations extend beyond the scope of standard metrics used for other AI systems. This necessitates basically the development of novel and domain-specific evaluations, which in many cases come from the business perspective, building those data sets and building those cases where the GenAI systems are then evaluated upon. This is something very different to what system engineers and data scientists and whoever else has yet encountered, whether we had metrics or standard performance indicators. Now this with GenAI shifts a little bit more to the business aspect and whether the AI system is performing the task at hand effectively rather than having some numbers that indicate its performance. So, how can we safely integrate GenAI into our workflows? There are some strategies that assist in mitigation of risks that we have seen while dealing with production-grade GenAI systems. Firstly, it is crucial to adopt effective containment strategies of our systems. These strategies must ensure the seamless and secure incorporation of GenAI technologies within our existing workflows. GenAI is a disruptive technology, but we must treat it in our operation in a way that is as less disruptive as possible for better ingestion and training process and integration of GenAI and transformation of the way we work. Another imperative way to mitigate risk is to invest in robust testing approaches. Basically, by customizing our testing to the unique requirements of GenAI systems, we aim for as comprehensive evaluation as possible. This means that we redesign and reevaluate the testing frameworks while dealing with each business domain and industry distinctively. Finally, strategic planning for unpredictability is another pivotal aspect. GenAI can sometimes produce unexpected and unwanted outputs. Thus, developing a robust contingency plan to address these outputs is key to ensuring operational resilience and continuity. Now, at this point, I want to give the stage and this remote to my friend and colleague Michael. Good luck with that. Who will continue to show us some case studies that we have encountered with GenAI in data operations in our experience.
Thank you, Bill. So I will try to go through a couple of our use cases and then try to shift a bit less on the technical side and more on the product management and basically how we envision GenAI in our future toolsets, etc. I hope through our use cases you'll see how we've already implemented some GenAI's insane potentials in a few parts of the market. So I'll try this. Perfect. Okay. So in this case study number 1, this comes from our loan contract analysis workflow. Our objective here with GenAI is to automate the process of retail loan processing by adding a mechanism for cross-validating client and contract information. Now, I'm going to walk you through our existing more of a traditional approach before GenAI. Well, we begin as usual. We use optical character recognition, or OCR for short. We digitize those PDF documents. We would then apply our AI models for document classification, and we organize these digitized documents effectively. So following this, we utilize traditional AI methods to extract critical data from contracts. Those data can be clients' names or contract numbers, signing dates, also everything else that has been defined in our project requirements. Now, a very important and significant advantage of this method is that it features measurable systems with adjustable confidence levels and allows for fine-tuned performance control on our end. So it definitely does not come without its challenges, for sure. As we discussed before, OCR can easily introduce errors, spelling errors, or anything else, depending on the quality of the original document and scanning. Now, this can translate into a reduced accuracy of the extracted data, and sometimes it comes with a long margin of error. Additionally, cross-validating information with other documents necessitates additional model development, which can be time-consuming and complex. It requires us to put constant resources into the project, even sometimes achieving marginally better results for a lot of effort. Now, this is where GenAI comes into play. Well, in the next slide, we'll discuss how GenAI can address these challenges and has already enhanced our workflow. Okay, so in this particular project, GenAI integration has mostly acted as a validation agent. So basically, it cross-checks information from traditional AI models, such as it will cross-check information from traditional AI models against other sources. So those sources could be different documents related to the same loan, or other documents that we have deemed crucial and significant. Now, the beauty of this is that it eliminates the need for further model development, cutting down a lot on complexity and time. But even though this was the original intention, it hasn't stopped there. The integration of GenAI has led to numerous improvements in our workflow. For instance, it corrects spelling errors and performs logical checks, ensuring client names are consistent across different documents. We have seen that it is able to provide smarter and more context-informed corrections. Those corrections have also proven to be reliable in most cases. Now, another significant feature that has been added in our workflow with this has been data transformation. We have used GenAI to convert data into formats that are either more usable or otherwise specifically required. Now, I have a specific example here. A simple example, the one we see here, would be transforming inconsistent date formats that we find across documents in many different forms into a standardized day, month, and year format that can be used into any systems later. Now, in truth, GenAI has elevated our data workflow. It has not just met the original objective. It has introduced validation, correction, and data transformation capabilities, effectively addressing plenty of the limitations that we discussed before with our traditional methods. I would also like to add here, as a note, we usually log both traditional AI and GenAI outputs separately. This allows us to compare and contrast the methods, iterate on the process, but also monitor the results. It has helped us understand the unique advantages that AI brings to the table, but also create flexibility and visibility with our deliverables. I'm going to move now to our second use case. For full transparency, this is based on a successfully completed proof of concept, and we will only be focusing on one specific requirement from that project. Now, it's important, this case was designed from the get-go with GenAI in mind, providing a fantastic example of what this technology can offer, even during the conceptualization phase. Now, the objective here has been to extract individual payment values from auction cases, along with their corresponding recipients. Here's how it worked. So we would load multiple documents, one or more, all pertaining to a single auction case. Then, we use the combination of methods to extract the required payment values and their corresponding recipients. And now here where it gets interesting. The payment values you're looking at cannot be explicitly found in those documents. This is where we leverage the LLM's advanced reasoning capabilities. We managed to create the necessary context within the documents, allowing the model to reason and calculate the final values. Now, impressively, it was able to add VAT, make additions and subtractions of various amounts, all without the explicit rules to guide it, as one might typically expect in such scenarios. This, to me, and to us in the team in general, showcases the immense potential of projects and products designed with GenAI in mind. With the right amount of development, fine-tuning, and the growing appetite for collaborative systems, we're really excited about the future prospect this technology holds. So this has been two use cases. I'm going to move towards a more generic view, our opinions about how we see GenAI included in data operations, but also in development in general. So with the rapidly evolving landscape of GenAI, we're seeing a significant revolution in the way we extract knowledge. GenAI moves quickly towards being increasingly sophisticated. That allows us to continuously create innovative methods to derive insights. This has been particularly impactful in scenarios, as we discussed before, where direct information is either not readily available or lacks the desired clarity and quality. So we've talked a lot internally about how we view this. We view this technology as an indispensable third eye. This is a phrase commonly used across different peoples. It has already worked for us as a validation agent in various scenarios, such as manual data entry, migration, automation processes. By doing so, it has significantly boosted both the accuracy and dependability of our operations. We have seen this already happen in our own projects, where we have been able to commit to higher accuracies and accept broader and more challenging requirements. Now, as we saw before, GenAI is not confined only to what is explicitly available. It has the unique ability to connect the dots. So, using multi-step reasoning and much broader contexts, it can uncover hidden or indirect information we might not be able to see otherwise. Now, I have an example here that can easily demonstrate this. For example, if we know a contract's start date, and we can find the duration in documents on the same cases or any other documents of the same files, GenAI tools can reliably predict the contract's termination date. Now continuing, we also see the immense potential of multi-agent systems. This is where multiple AI agents interact and work together. Such a setup can solve problems that may be difficult or impossible for a single agent to tackle. We've implemented this approach from the early stages in our life cycle, initially with traditional AI tools, which have expanded both the breadth and the services we can offer, and also the quality of those deliverables. Now, I'm certain we share the same notion here, but GenAI has been a fantastic addition to our toolkit. Now, we see that AI solutions can greatly benefit from incorporating high-performing GenAI solutions in their architecture, particularly when trying to create systems capable of producing and processing real-time data. This is a trend that has the ability to expand the horizons of AI applications. We believe as we continue to explore and harness this potential GenAI, we're not just expanding and transforming our own approach to extraction knowledge and information processing, but we're actually revolutionizing it. Now, as we dive deeper into the technology, there are more things coming with GenAI. We can look at how we can expand our horizons with multimodal GenAI. So multimodal GenAI integration allows us to process diverse data types from text to images to audio and videos, This opens up an array of innovative solutions, enhancing different aspects of our traditional operations. This does not mean only more data. It is a shift towards more comprehensive analysis. GenAI has the ability to digest, extract, and synthesize information across multiple modalities, giving us a holistic view of our data. This includes data that we have not thought of using before. This paves the way for cross-disciplinary insights, breaking down barriers between different types of data and unveiling connections that may have otherwise remained hidden. We'll consider a real-life example here. We thought about the potential example of environmental monitoring. So you can imagine a multimodal GenAI system that analyzes satellite images to detect deforestation. But this system will not stop there. This system can then cross-reference visual data with relevant environmental regulations based on the given geolocation. We think this showcases the power of multimodal GenAI, turning disparate data into actionable insights. Now, in our opinion, and I think this is important, it also invites a new level of collaboration across different aspects of an organization, where diverse data types, data formats, or data volumes are handled. As we have been suggesting, GenAI has a relatively small barrier to entry in terms of resources or data quality needed. We see this enabling teams that would not have had the opportunity before to share their insights and their creativity. So to echo the sentiment of our previous slide here, with GenAI, we're not just expanding our horizons, but we're redefining them. Now, for the final bit, we'll try to share some of our thoughts regarding the transition to a GenAI inclusive future. To start, we believe it's crucial to lay out a strategic plan for its adoption. We suggest beginning by formulating a roadmap for integrating GenAI into your own data operations. Identify key areas that align with your organizational goals and your planned projects. Importantly, we would also suggest to try and include wider industry goals in this discussion. There's a possibility that new solutions or shortcuts will be emerging from the process. Now, remember, you don't need to redefine the whole landscape at once. We found ourselves that starting small and aiming for quick wins can provide valuable hands-on learning experiences and also familiarization with the technology. It's crucial to adopt a fail-fast approach, valuing iterative learning and swift experimentation as stepping stones to success. But now we're going to move to my favorite part, which is cultivating the right mindset. Preparing for a GenAI-driven future is not just about the technical integration. It's equally about fostering the right approach. We urge you to prioritize education in AI fundamentals and understand what AI can and cannot do in general, but also for you. Define its limitations within your own requirements. Promote a culture that encourages innovation and exploration. Signify the importance of critical thinking. Be prepared to discern the practical applications of GenAI from the hype that surrounds it. So embracing out-of-the-box thinking is a very beneficial step. I think it's really difficult to indulge in completely. We find it difficult ourselves. The current set of tools arrived with their corresponding weaknesses, and we have learned to tolerate them, but also we have adapted to them. I believe looking away for a second might create a change that might be needed on our problem-solving approach. Now, finally, I think you should welcome collaboration and partnerships. Shared learning and collective action can significantly accelerate progress in this rapidly evolving field. And of course, we are big proponents of that. Now, this is all we wanted to share this morning. We're happy to answer any questions or just listen to your opinions, hear your thoughts on GenAI or AI in general. Thank you.
We have a question. Yeah. They're bringing the microphone.
Hello. Yeah. Hi, my name is Konstantinos Neophytou. I work for Benevolent AI. I really enjoyed your presentation. Thank you. It was very interesting, and as well the use cases you presented. I had a question regarding specifically around a portion of the examples you brought around, for example, well, a few pieces, but for example, connecting the dots and stuff like that. Mm-hmm. I mean, there's a known problem with traceability and some hallucination around GenAI models. How do you validate that the results that the GenAI model is presenting are accurate? And if you don't, how do you ground that, how do you verify that it is grounded basically in what you provided? I don't know if I made myself clear.
Yep. Well, I think this is why we initially highlighted the traditional AI methods that basically can incorporate a measurable they are measurable systems. So basically we can define many thresholds, we can define many things that we have a clear visibility on. And we definitely wanted to highlight the risks as well by using GenAI, which is, as you definitely correctly mentioned. I think here what we are mostly trying to do is combine different systems together, and those systems can feed into each other. And those systems can give us outputs that we can then use to validate. It's not easy to give you a specific example on those use cases, but it's definitely worked for us to try and find different methods to explore solving basically a solution. But even though hallucination is a risk, we've definitely seen that using cross-collaboration between systems has helped a lot.
Yeah, I just want to add one more thing to that. So what you said is a main concern, right, for everyone building a system around GenAI, hallucinations, inconsistent and unpredictable outputs. And that is why designing such systems from the ground up not only is very crucial to build those validation data sets correctly, but imagine the different components of the system, like traditional AI systems or basic, let's say, standard software engineering, validating the output of the GenAI system. So the GenAI system produces something that can be anything, basically a non-deterministic output, and you give that output to a traditional AI system or a software validation mechanism, and you basically take it a tier down, you dumb down the problem in order to validate whether that is valid or not. So the main problem is solved by GenAI, and the validation of the output of the problem is handled by a different measurable system. I hope we answered the question.
No, thank you very much. I mean, when I saw that you have the GenAI generate like a total number and adding and subtracting out of various, I was like, yeah, I'm not comfortable with that. But then again, I work a lot with scientists who like just dismiss everything they can't see. So it's a different problem.
That. I think it's very important also to educate the client or the people that come with the requirements to you to what they can expect. Not only your own team to how to use the limitations, but also what the prospective clients could expect or the industry in general.
Yeah, we have a couple more questions.
Okay, hi. My name is George. I'm from the MFA. I would like to a couple of quick questions. First, for someone who has no real experience on GenAI and wants to get involved, would you advise him to learn Python, for instance, or it's just that, you know, GenAI will gradually end up coding itself, so you really don't need that. And about prompt engineering, there's a lot of hype. Like, it's the next big thing, but also there's the idea that eventually you will get the right answer by the right question by the system itself. Like, you don't need to, be so much into it. Thank you.
Great question. Thank you for the question. Even the greatest fighter jets need the best pilots. So basically, the best system, you can have the best system, the most reliable system, but you still need the people educated enough to pilot the system to produce what you want them to produce. And that goes to your second question about prompt engineering. Prompt engineering in prompting in general is a technique that falsely is thought of, I am asking something and I am expecting the system to understand and produce me something that I do not know. You have to know and you have to understand what you're asking the system to do in order to get the best result you want. So in the case that we're talking about GenAI replacing coders, software developers, etc. To a point, yes. To a point, yes. But it will be the system that will be just typing the thought of the engineer, not thinking it through the whole process and laying out the plan that needs to be done. Because each case, its system, and each use case, it's so unique that you have to have the fundamental knowledge, which maybe is not a specific, for example, Python or programming language, but you have to have the fundamental knowledge of what you want the system to do. That's about the prompt engineering. And I'm sorry, what was the first question?
Python or Python,
okay.
or
where
will
to
it
start?
be able
yeah,
to?
where to start? So,
you can continue that.
Okay.
I'm a product lead.
So where to start? Basically, for everyone wanted to take the first step. I wouldn't say programming is the first step. I would say information around the technology is the first step. Okay, learning how to pilot the information. Let's say on something very basic, the internet now, right? You don't have to know how the internet works, what are the requests, the protocols, etc. You have to know where and when to go, how to search something you want, how to operate something you want, and how to filter the results and the capabilities of what the technology can and can't do. So starting, I would advise someone to dive deep into the edge cases of the AI systems. Because the edge cases are the ones exploring the limitations, not the base cases. Because the base cases can solve a certain amount of problems, but in complex problems, which is business problems, and we're trying to solve complex problems, you will encounter the limitations and you will go to the edge cases and you will see you will require from the system to do the extra step, and that's where you need to know that the technology can do this step or is limited.
Yeah, sorry. I have a small thing to add here, and then we can pass the microphone. I think it's been a cursing and a blessing that OpenAI with ChatGPT has made this the technology widely available. It's made it really popular. But it's also imprinted in the minds of people that this is more of a conversational side to the story, and it has the ability to understand or feel or all of those confusing and contrasting feelings around the subject in general. And we see it more as a tool, as a technological advancement in many things, just a progression or basically a different direction on previous methods. So it's definitely important to educate yourselves around this part. So I agree a lot with Vasilis. Sure.
Yes, we're a little bit out of time, so...
Hello. Hello.
Okay.
I'm Dimos Komatas from We Are 8. Now, thank you for your presentation, guys. Now, at least on 2 occasions, I think one each, you mentioned the multi-agent systems. And I would like you to just a little bit elaborate a bit on those, because I don't really get the connection with GenAI, maybe the traditional AI tools. Yes, we are a social media company. I know our use cases for that, and it's pretty much 100% simulation and emergent behaviors, but I don't really get how you connect the multi-agent system aspect to GenAI. Just a couple of sentences.
Yeah, absolutely. Okay. Modular systems, basically. What are they? What's the premise of a multi-agent system? A premise of a multi-agent system is that when you're trying to create an agent, a system, a software that performs a single operation, and you're focused to one operation, then you are bound to make it better and more complete than building a monolithic architecture, right? So multi-agent systems are basically doubling down in this mentality of modality and create GenAI systems that perform singular tasks very efficiently and binding them in a team with a coordinator agent, that his job is to route the specific tasks to the GenAI agents that are very good and can be tuned to a specific one task. This enables much better testing over the system and enables much better scaling of operations and changes in the future, because it's a lot easier to create GenAI agents and then shift their ability in a task to perform it in another way that you're thinking than, again, managing an entire, maybe big GenAI system that can do 10 or 20 or 100 things together. So basically that is our perspective and on what AI multi-agent systems do. Okay, we haven't run out of time, and thank you all for coming.
Thank you.